All right, here we go. A thermometer reading 5 degrees Celsius is brought into a room with a constant temperature of 35 degrees Celsius. If the thermometer reads 15 degrees Celsius after 4 minutes, what will it read after being in the room for 6 minutes and then for 11 minutes? So let's look at the first question. It says, after 6 minutes, the thermometer will read, and we need to fill in the blank there. And it's noted that we do not round until the final answer, but then at the end, we're going to round to the nearest hundredth as needed. Okay, so here we go. First of all, we need to set up the equation. And as we set up the equation, we're going to be using, since we're talking about degrees here, looking at Newton's law of cooling, where we're going to use the U of T equation equals to T, that's the temperature of the surrounding environment, plus U sub zero, which is the initial temperature of the object, minus T times e to the k times T power. K being the constant cooling rate of the object. T time in minutes. So we're going to use this formula here to answer the question. Newton's law of cooling. So I'm going to rewrite the equation again because we need to fill in some information that's noted in the problem. We have U of T is equal to capital T plus U sub zero minus T times e to the kt. All right, so what is noted here? It says a thermometer reading 5 degrees Celsius. So this is our initial temperature of the object here. So our U sub zero is 5 degrees Celsius. And then it says it's brought into a room with a constant temperature of 35 degrees Celsius. So our constant temperature, our capital T, which is 35 degrees. Okay, so we're looking to, before we can answer the question, we need to set up our equation. So let's plug those values into the formula. We have here 35 plus, in parentheses, we have 5 minus 35 times e to the kt. And keep in mind that is degrees Celsius. Let's subtract 5 and 35. We have negative 30. So we have 35 minus 30 times e to the kt. So we need to finish setting up the equation where we need to find k. So if we go back to the word problem itself, it says after 4 minutes, um, it says if the thermometer reads 15 degrees Celsius after 4 minutes. So we have here what's given, the time, which is 4 minutes, and we have the temperature at the time, which is 15 degrees Celsius. So that would be our U of T. So let's plug this in. So we need to find K. So we have 15 is equal to 35 minus 30 times e to the k times 4. So we would say 4k. So let's work to get our base E by itself. So we're going to subtract 35 to both sides. And 15 minus 35, we have negative 20 equals to negative 30 e to the 4k. Divide by negative 30. And we know that now if we want to reduce negative 20 over negative 30, we can, or we can keep it as is. Let's reduce this left-hand side. We have positive 2/3 equals to e to the 4k. And then we're going to take the natural log to both sides. And we have ln of 2/3 is equal to 4k. Divide both sides by 4. And we have k is equal to, so let's go ahead and plug that into our formula. Let's plug this into the calculator. So let's do ln of 2 divided by 3. I'm going to press enter, then divide by 4. And we see what we have for k here. Negative 0.101366,277. All right, so now we have everything that we need so we can set up our equation uh, to answer the two questions. Okay, so here we go. Let's get another sheet of paper. All right, so we have everything that we need to create the formula and answer the question. So we have u of t equals to 35 minus 30 times e to the negative 0.101366,277t. After 6 minutes, the temperature will read. So let's go ahead and we're going to, since 6 minutes will be our time, which is our t, let's plug t in for 6 minutes in for t. So we have 35 minus 30 e to the negative 0.101366,277 times 6. So let's multiply that decimal in 6, the exponent. Let's see what we get there. We have here a negative 0.101366,277 times 6. So let's write that out, this decimal component here. 35 minus 30 e to the negative 0.608197662. All right, so now I'm going to kind of work backwards here as I enter my information. I want to first find out what is e raised to this negative power. So second in ln, that gives us our base e, and we have negative 0.608197662. I'm going to close it, press enter. Then I'm going to times 30 to that. And then I'm going to write 35 minus, and then I want to recall my previous answer. So I'm going to press second and the negative key that is below the number 3, and then press enter. Okay, so then it gives me, or gives us, 18.67. Okay, and we can round this off to being what here? Or do we need to round? It says after 6 minutes the thermometer will read 18.67 degrees Celsius. We all see when we round to the nearest hundredth after 6 minutes. Now we're going to do the same thing for 11 minutes. So we're going to substitute 11 in for T. So we have U of 11 is equal to 35 minus 30 e to the negative 0.101366277 times 11. And let's multiply the exponent component. Do this in parts. It'll help you out with making sure you have the correct answer as you enter the information in the calculator. So we have negative 0.101366277 times 11. Okay, so you see what we get as a decimal. 0.115029047. All right, so how I enter this into the calculator. Let's move this over a little bit so that you can see. Let's put in our base E first. So we have base E and we have negative, or let me erase that. Base E, we have negative 1.115029047. Press enter. I'm going to times 30 to that. And then 35 minus, and then my second and my previous answer, and it gives us 25.16282738, but we're going to round to the nearest hundredth, so we will have 25.16 degrees Celsius after 11 minutes.